Hello, welcome back. In this video, we're going to really get into talking about some trigonometry. We're going to talk about sine and cosine. So, in the last video, we talked about the 30, 60, 90 triangle and the 45, 45, 90 triangle. But the question is like, okay, what if I got a right triangle where it wasn't 30 degrees or it wasn't 45 degrees? Like, how could I find x? But to get there, I think we need to start all the way back to the basics. So I need to remind you that the angles of a triangle add up to 180 degrees. And if we know two angles of a triangle, we can find the third and thereby define the shape of the triangle, right? So if we know that the two acute angles of this triangle right here are 20 and 40 degrees, then we could find x by, solving an algebra equation. So we could say that we know that 20 degrees plus 40 degrees plus x is going to be equal to 180. And then we can, this is not a very difficult equation to solve, but we can combine like terms. Okay, subtract 60 and see that x is going to be 120 degrees. Now, if we know a triangle has isosceles and we know one of the angles, we could solve for the other angles using algebra and then, of course, know the shape of the triangle. Okay, so if we knew that those two, vertical looking legs were equal, okay, we would know that the angles across from them were equal, and so that's going to be x equaling 70. Okay, but then we know they, in total add up to 180, so we could say, all right, well, 70 plus 70 is 140, so that would mean that y would have to be the other 40 to be 180. We could do the same thing if we were given just the upper angle. Right, we could say if we knew that the angle up top was 20 degrees and we were looking for the other two, we know they're equal, so it's like 20 plus 2x equals 180, so 2x would equal 160, and we could say that x was equal to 80. And really the one that we're going to be mainly interested in is if we know that we've got a right triangle, and we know one of the angles, then we can solve for the other angle and know the shape of the triangle. Okay, so if we knew that this was like, 50 degrees, and we know that the total has to be 180, and we were looking for this one, so we called it x degrees. Okay, we would know that 50 plus 90, because that little square indicates right angle, plus x is going to equal 180. You could also just say 50 plus x has to equal the other 90. Okay, but that would be kind of implicitly knowing that you were subtracting away that 90 there. Okay, but what we would say is that, okay, x is going to equal 40 degrees. And then next, I guess I would say, if we know two triangles have the same shape, we don't know that they necessarily have the same size, right? We can see that these two things have the same shape, but not the same size. Okay, but if we did know that two triangles had the same shape, and we knew the proportion of the sides, we'd only need to know one side length to know the other two. So what I'm saying is, if we knew that the size and shape of this one on the left, and then we knew that these were similar triangles, and on the right this side length had this side had length 10. Okay, then we know that the second triangle is twice as big. So we would know that this one's 14 and this one would be 6. What I'm saying here is that we can know everything there is to know about a triangle if we know its shape and its size. So for a right triangle, if we were to know one of the non-right angles and one of the side lengths, we'd be able to know everything there was to know about it, because if we knew one of the non-right angles, we'd know the other one, and if we knew one of the side lengths, having already the shape, okay, we could, know the exact size. All right, so let's get to the good stuff, the good old-fashioned trigonometry. So we're going to start by defining the trig ratios. And, I think a lot of times, most classes, when you're just talking about defining things in general, you're going to have a right triangle and you're going to have some reference angle, the angle you're mainly talking about. And that's that angle we're talking about right there. We're going to call that theta. Okay, theta is just a Greek letter. But it's going to be a variable that means some sort of angle. Okay, the vertical leg, we'll probably call that y. The horizontal leg, we'll call that x. We might call the hypotenuse r. Okay, so sine of theta, okay, what you need to remember from geometry is SOHCAHTOA. What that is just like a mnemonic to help us to remember the values of sine of an angle, cosine of an angle, and tangent of an angle. Okay, so if we're talking about this theta right here, we've got the hypotenuse. That's always going to be the side that's across from the right angle. It's the longest side on a right triangle. And then we've got two legs. Okay, so there's going to be a leg that's closer to the angle that we're talking about, theta, that's going to be x. Okay, we call that the adjacent leg. And then there's the other leg that's farther away. That would be y. Here we're going to call that the opposite leg. So that when we say SOHCAHTOA, we say sine theta is opposite divided by hypotenuse. Okay, and in this case, that's going to be y divided by r. Okay, cosine, ca, adjacent over hypotenuse. Okay, in this case, that's going to be equal to adjacent's x and hypotenuse is r, so x divided by r. And tangent is opposite over adjacent. Okay, which is going to be y divided by x. Okay. Now these other three, these are three you might not have seen in geometry class. Okay, these are secant, cosecant, and cotangent. These are definitely not going to be like the most important thing we talk about this year in Algebra 2, but they're just something I want you to be familiar with, you know, by the time you hear about it in pre-cal. Okay, what these are, they have geometric meaning in terms of like a, you know, a triangle and an inscribed or a circumscribed circle or something, you know, that whole thing. For us, cosecant is 1 over sine, and just it's like it works the opposite of the way you would expect. Okay, so cosecant is 1 over sine, so it's going to be y divided by r. Okay, and I'll put in the you know the things that we're supposed to remember off to the side. Secant is 1 over cosine, so if we take 1 over x over r, we take 1 over a fraction, that effectively just flips the fraction. So it's going to be r over x, and then cotangent, that one's the opposite of tangent, just like you would expect, so that's going to be x divided by y. So what we want to remember here is just that cosecant is the reciprocal of sine. So cosecant theta is 1 over sine theta, secant theta equals 1 over cosine theta, and cotangent of theta equals 1 over tangent theta. All right, now let's do some examples. So I've got my calculator out, because that'll be necessary if we're not working with 30-60-90 or 45-45-90, which we're not going to. And I need to be in degree mode for what we're doing here today. And you know, the default for these TID3s or TID4s is going to be radian mode, because in general, radians is definitely the superior measure of degrees. I mean, no, not degrees, the superior measure of an angle. But for now, we're going to need to stick to degrees because it's what you're familiar with. You know, in a couple of videos from now, we'll talk about radians and what all that means, and we'll probably, you know, soon enough, next year, we'll leave the degrees behind. Okay, so we're going to quit out to the main menu. What we got to do, I'm going to work this top left one, is we just got to set up a certain ratio that'll have an x in it, and we'll solve there. Okay, so I've got this angle right here, and I've got a leg and a hypotenuse. Okay, and oh no, my PC battery is running low. I have to plug that in. So if I've got the adjacent leg and the hypotenuse, SOHCAHTOA, that's going to be cosine. So I use cosine. I'm going to say, all right, cosine of 40 degrees is going to be equal to adjacent, that's 8, divided by hypotenuse, which is x. I'm going to solve this equation for x. But, you know, I'm going to only try to use the calculator once. I don't want to, like, carry around a bad decimal number, because you're going to find cosine of 40 degrees, not a great number. Okay, so I'm going to just try to solve for x first, carrying around cosine of 40. I'm going to multiply both sides by x. And then solve for x by dividing by cosine of 40, and that's 8 divided by cosine of 40. Whoops. And that's something I'm going to find with the calculator. I ask for a fraction bar. On top, I'm going to put 8. On bottom, I'm going to put cosine of 40. Okay, since we're in degree mode, it knows we're talking about 40 degrees. That's going to be 10.443. Why don't you try the one on the right on your own, the one on the upper right, 5x and 29 degrees. Okay, I'll give you a hint, it's not going to use cosine. Okay, so you set up a trig ratio, solve for x using the calculator, you know, check your work against mine, so you're going to need to pause the video now because the answer is just going to pop up in a couple seconds. All right, there you go. So we found that x was equal to 10.313 when we just kind of went through the exact same process as the last time. I said to myself, all right, I've got the opposite side and the hypotenuse. So it's so and SOHCAHTOA, so I need to use the sine ratio. And then sine of 29 degrees is opposite divided by hypotenuse, that's 5 divided by x. I can solve for x. And what I liked about this is that this makes a lot of sense. Okay, you know, in keeping with what we learned in the last video about 30, 60, 90 triangles. 29, really close to 30 degrees. So I would expect x to be, x the hypotenuse to be really close to twice the length of the shorter leg. So it'd be really close to 10, and that's what I saw. Yeah, I'm going to work this one in the bottom left for you. Let me just get that looking better. Yeah, I'll do the one on the left, and you can do the one on the right. All right, so over here, I've got 53 degrees. And so x, just because it's the horizontal leg, doesn't mean it's necessarily the adjacent angle. It's opposite the 53 degrees, so that's opposite and hypotenuse, so I need to use sine. So I'm going to say sine of 53 degrees is equal to opposite divided by hypotenuse. If I'm solving for x, I'm just going to multiply both sides by 6. So x equals 6 times the sine of 53 degrees. And we're going to be able to run that through the calculator pretty quick. And we get 4.792. Okay. So now you try it on your own with one on the right, and see what's going to happen. Do this with the video paused, because again, I'm just going to work it and pop up the answers here. All right, there you go. So this one, gave me an angle and the two legs, so I know I'm going to have to use tangent. Tangent's opposite over adjacent, 16 over x. Okay, I didn't really have that much room, but we saw it happen twice on the upper two examples where, where the x was in the denominator, we ended up multiplying it across, dividing the trig ratio. So I don't think it's too much to say, all right, x is going to be equal to 16 divided by a tangent of 70 degrees, and that's going to be 5.824. And now I know that I don't always draw these figures exactly to scale, but it's always good to check and just make sure that, at the very least, the hypotenuse is the longest leg. But based on this one, you can see that, okay, 16 is clearly bigger than 5.824, and so that would make sense. And for the 53 degree one, we just need to make sure we're getting a number that's less than 6, right? If we got 7 point something, that would be a bad sign. So I got 4.792. That looks like very believable for that drawing, and so I think I can move on. All right, now here's a slightly different type of problem. Find the values of the 6 trigonometric functions of x, where they give us 2 of the side lengths. Okay, now you could go in and say, all right, this is going to be an a right here, and a squared plus b squared equals c squared, and solve that out yourself. But I'm just going to tell you this is a Pythagorean triple. Okay, everyone knows 3, 4, 5. I hope you've already heard about 5, 12, 13, but if not, that's a Pythagorean triple as well. Those are both pretty common on the SAT, ACT. But 9, 40, 41, I feel like people don't know 9, 40, 41 enough. I like to use that one a lot when I taught pre-cal. So I'm just going to tell you that this side length is going to be 9. And you can check and make sure that 9 squared plus 40 squared equals 41 squared, but it does. Okay, so sine of x is going to be opposite divided by hypotenuse. So this one's going to be 9 over 41. Okay, cosine of x is the adjacent leg divided by hypotenuse. Tangent is going to be opposite divided by adjacent. And I just told you about these a couple minutes ago, but secant, cosecant, and cotangent, we just need to remember, okay, secant is 1 over cosine, so it just flips cosine. Cosine was 40 over 41, secant will be 41 over 40. Cosecant is the reciprocal of sine, so if sine was 9 over 41, this will be 41 over 9. Cotangent, that's the reciprocal of tangent, that'll just be 40 divided by 9. All right, now the last new thing I got to show you is how to find the values of these things using a calculator, because that can be a little tricky if you just aren't, totally remembering what to do. Earlier I told you that cosecant of theta was 1 over sine theta, secant of theta was 1 over cosine of theta, and cotangent of theta was 1 over tangent of theta. So we're just going to use that. I'm going to say secant of 68 degrees is 1 over cosine of 68 degrees. We're going to bring in a calculator, ask it for the exact same thing, and get 2.669. Okay. We can do the same with cosecant and cotangent. Write them in terms of their reciprocal identity. Ask the calculator to do exactly that. I would suggest using the fraction bar. And obtain yourself some answers. So we can see that cosecant of 14 degrees is going to be 4.134. And then cotangent of 40 degrees is going to be 1.192. Okay, so that's how we're going to evaluate secant, cosecant, and cotangent on the calculator. And I know I said that was it, but I found one more problem type that I want to show you about. So I wanted to show you how to solve this type of problem. So if they tell you the cotangent of theta is 4/3, and they could ask you what sine of theta is, and we should be able to figure that out. So what we're going to do is we're definitely going to draw a picture. It doesn't really matter how to scale it is, it just needs to be a right triangle. All right, so if cotangent of, in fact, I'm going to make this one really out of scale. So if cotangent of theta is 4/3, okay, that means to me that, actually I guess this one will be in scale, that tangent of theta equals 3/4, because we don't really have SOHCAHTOA for the other ones. I'm sure you could, make one up, but I don't think that'll be necessary. So if we know tangent of theta is equal to 3/4, okay, that means opposite divided by adjacent is 3 divided by 4, and the easiest way to make that happen would just be the opposite being 3 and the adjacent being 4. And if that was the case, that would mean that the hypotenuse would be 5, because 3 squared plus 4 squared equals 5 squared, because 3, 4, 5 is a Pythagorean triple. And I could say sine of theta, okay, that's going to be opposite divided by hypotenuse. That's going to be 3 divided by 5. So why don't you try this one on your own? Cosecant theta equals 41/40. Find tangent of theta. It's going to be exactly the same, except you might need to remember what I told you just a few minutes ago, that 9, 40, 41 is a Pythagorean triple. Okay, so try this on your own with the video paused, and then check your answers against mine, which will pop up in a couple seconds. All right, there you go. So just like before, I say, okay, if cosecant is 41/40, that means that sine is the reciprocal of 40/41. Draw myself a little diagram. Okay, see, this one's horribly out of proportion, right? The short leg is 40 and the long leg is 9. Okay, whatever. Okay, if sine is 40/41, that would mean that, I had the opposite leg being 40, hypotenuse being 41 in the simplest case. And then I could, okay, 9, 40, 41 is a triple. I can put that third leg in there. And then I say tangent theta, that's opposite over adjacent. That's 40 divided by 9. All right, so I think that's all the problem types I got for you for this video. Come back for another one. We're going to do some inverse trig, do a whole bunch of other trig topics. But thanks for watching.